Okay, so this is the problem. Y is e to the power negative x, tan inverse 2 times e to the power x. We need to check either this is a solution of this equation or not. To check that, you need to find out y prime, and you need to add y prime with y. That should be this part. This y prime means it's a derivative, and then the condition is when you replace x by negative ln2 in y here, that should be pi over 2. So first of all, to find out the y prime, you can see that y is a multiplication of e to the power negative x times this one. There are two different functions. So to find the derivative of this function, you have to use the product rule. Derivative of the first part times the second plus first function times the derivative of the second part. So the big thing is you have to know the derivative of this tan inverse of 2 times e to the power x. So I'm going to use different file here. So this is the standard formula for derivative of tan inverse of u. U stands for anything, function of x. With respect to x, this is the formula 1 over 1 plus u square times the derivative of whatever comes inside this parenthesis with respect to x. In our case, inside this parenthesis there is a 2 times e to the power x. So derivative of this function with respect to x is 2 times e to the power x. So derivative of tan inverse of 2 times e to the power x is this part, which is 1 over 1 plus u square. If u is 2 times e to the power x, then u square means 4 times e to the power 2x times dy over dx, which is 2 times e to the power x. Now we want to find out the derivative of y. Remember, y is the product of two different functions. So if y is f times g, then the derivative of y is derivative of the first function times the second function, the first function times the derivative of the second function. In our case, f is e to the power negative x and g is this inverse trig function. So the derivative of y is derivative of the first function, which is negative e to the power negative x times this one plus the function times the derivative of this part, which we already found, that is 2 times e to the power x over 1 plus 4 times e to the power x. So here we cannot do anything, this is already simplified, but here there is e to the power negative x and e to the power x. If you just simplify this, they will be cancelled out, so you can find 2 over 1 plus 4 times e to the power 2x. So this is the derivative of y. So let's just type this thing here. So derivative of y is negative e to the power negative x tan inverse 2 e to the power x plus 2 over 1 plus 4 e to the power 2x. Let's check it one more time. It's a negative e to the power negative x times tan inverse 2 e to the power x plus 2 over 1 plus 4 e to the power 2x. So that's the derivative we found for y. So let's check it. That's good job. So now we have to add y prime and y. As you can see that if you add y and y prime, the first part here and here, they look very same, but there is a negative sign here. So when you add these two, this first part and this will be cancelled out. The only remaining thing would be this one. So let me just type 2 over 1 plus 4 e to the power 2x, and that is exactly the right side of this equation. So that means when you add the derivative of y and y itself, it should be 2 over 1 plus 4 e to the power 2x. That's good. Finally, we need to check that what is the value of y when x is replaced by negative ln2. So go here, just replace wherever you see x, replace it by negative ln2 and use the property of exponential and ln. It will give you, definitely it will give you pi over 2. That's great. So just replace x by negative ln2, and this negative and the negative from here will be cancelled out. E to the power ln2 is actually 2.